A seismometer is an instrument used to detect and record ground vibrations. Its basic principle is based on the movement of a mass relative to a frame that moves due to ground motion. In this video, we will discuss the equation of motion for a seismometer. Part 1. Basic principle of a seismometer. A seismometer consists of a mass suspended by a spring inside a casing that moves with the ground. When an earthquake occurs, the casing moves, while the mass tends to remain stationary due to inertia. The relative motion between the mass and the casing is measured to record vibrations. In this system, three main forces act on the seismometer mass. Spring force, given by F equals kx, where k is the spring constant. Friction or damping force, which is proportional to velocity and has a coefficient d. Gravitational force, which acts on the seismometer mass m. If we write the force equilibrium equation for this system, we get the fundamental differential equation for the motion of the seismometer. Part 2. Equation of motion. We can express the equation of motion for this system as follows. This equation shows that the acceleration of the mass relative to the casing depends on the damping factor and the natural frequency of the system. Damping constant, epsilon, indicates how quickly oscillations decrease over time. Eigenfrequency, omega, is the system's natural frequency, which depends on the spring constant and the mass. Part 3. Conclusion. This equation helps us understand how a seismometer works and how system characteristics, such as damping and natural frequency, affect its response to ground vibrations. By understanding this theory, we can improve the accuracy of instruments in recording earthquakes. That was a brief explanation of the seismometer equation of motion. Hope you found it useful, and see you in the next video.